Okay, guys, I'm back. I've got the open response question here that you had on your test, and so we're going to go over that pretty quickly because I have to go to parent-teacher conferences like in just a second. So we're going to look at this first question. Let's look at number 2. Answer the following questions related to the solubilities of 2 silver compounds, silver chromate and silver phosphate. So we have the silver chromate dissociates, and so all you have to do on A is to simply write the equilibrium constant for the dissolving. All right, so let's start that off on A. Okay, so we're going to write KSP equals AG positive squared. And then we've got the chromate CrO4 2 negative, and then you're done. And so that was worth 1 point on that question. Okay, if you didn't get any credit for that, then you either didn't write it correctly or you didn't write it at all. I think most people got credit for that question. Okay, then B, we have calculate the concentration in moles per liter of silver ions in a saturated solution. So if you look at what they gave us, they gave you the KSP value of 2.6 times 10 to the negative 12. Okay, so if we plug that in, 2.6 times 10 to the negative 12, then we're trying to find the solubility. Remember, solubility is your X. So if you plug in 2X for silver, because remember, in the equation, you had twice as many of those. And then don't forget to square that. And then this one would just simply be X, okay? Which will simplify down to 4X. And then you've got a squared times an X, so that would be 4X cubed. So bring this down. You're going to divide by 4, just like we've done in the previous example. And then you're going to need to take the cube root of both sides, okay, in order to solve that. So X, which will be your solubility in moles per liter, is equal to, let's plug this in real quickly. So 2.6 times 10 to the negative 12 divided by 4. And then I want to take the cube root of that and grab that. Enter. And so I got 8.66 times 10 to the negative 5th. Okay, 8.66 times 10 to the negative 5th. And let me double check something because I need to make sure I see what the question asked. And I was assuming that it said calculate the solubility, but it says calculate the concentration of silver ions. Okay, so what we have done is we calculated the solubility, which is X, but remember that the silver ions were 2X. So we would need to take 8.66 times 10 to the negative 5th times 2, and that's going to give us what our final answer is. I think there were 2 of you that actually got the right answer on this question. And because as I misread the question whenever I did this, I just got it to here, and I'd originally given that, gave you a point if you got this part in, and then I gave you a point for your final answer. And actually, it should have been a 3-point question, but I ended up giving a bonus point. So if you got a bonus point on this question, this is where it came from. Final answer is 1.73 times 10 to the negative 4th molarity or moles per liter. Okay, and so that's for the silver ion concentration. All right, now, next question. In C, calculate the maximum mass in grams of silver chromate that can dissolve in 100 milliliters of water at 25 degrees Celsius. All right, so here's what we're going to end up with. We want to end up with grams of silver chromate. Okay, so let's think about what we have. We have this piece of information that we are going to use to start with. That's the solubility of silver chromate. It's just in moles per liter. We want the grams of silver chromate in 100 milliliters of water. So it's just really, guys, it's a unit conversion problem. We're going to take our 8.66 times 10 to the negative 5th moles per liter, because that's how much can dissolve for the silver chromate, and we're going to convert that into grams per 100 mils. So let's get rid of the liters. For every 1 liter, there are 1,000 milliliters, and we're trying to get that for 100 milliliters. So I'm going to put 100 milliliters up here, and I don't have to put anything down here. Okay, so milliliters will cancel, and right now that would be the number of moles in 100 milliliters. And now I need one more conversion to get us to grams. And so if I look up the molar mass of silver chromate, I believe it was 330 something. Be right back. Actually, I have these already written out. 331.72 grams in 1 mole. Right, so moles are going to cancel right here, and you're left with grams. So then you just need to do your dimensional analysis there. Okay, so I'm going to start with, it's like the 8.66. So I'm going to go up and just capture that number. 8.66. Never mind, I didn't do that. Let's try it again. I need to type it in. 8.66 times 10 to the negative 5th. And then I'm going to need to divide by 1,000, multiply by 100, times 100, and multiply that times 331.72. And I got 0.00287 grams, 0.00287 grams of silver chromate would dissolve in 100 mils of water. Okay, you turn that, that's kind of crooked. All right, let's look at the next question. I'm sorry I'm kind of rushing through this, but I have to go do parent-teacher conferences here in just a second. Okay, last part of that question is, or at least on that part, D. A 0.1 mole sample of solid silver nitrate is added to a 1 liter saturated solution of silver chromate. Assuming no volume change, does the chromate ion increase, decrease, or remain the same? Justify your answer. Guys, this is a multiple choice question. Okay, so let's look at what I've got on here. Oh, by the way, I didn't tell you how many points that other question was worth. So let's look at C real quickly. You got a point if you converted your liters to mils. I saw some evidence that you did that. You got a point for the correct molar mass, and you got a point for the final answer. So that particular question was worth 3 points. All right, so if you got a 2 out of 3 on that, that's where you missed a point somewhere along the way. You may not have even included this number in it, and so I probably made a note on your paper. All right, let's move on and look at D real quickly, and you can go back and rewind this video if you need to. So what you're doing here is you're adding more silver chromate. I had some people that said, well, I'm adding to this side of the equation. You're adding silver nitrate. In solution, these two things aren't together at all. They're actually silver ions and nitrate ions. We don't care about the nitrate because it's not part of this reaction, and it's always soluble all the time. So it's just a spectator ion. It's not that it's not there, it's just not important to us. So you added some more silver ions to the solution. The reaction is going to shift to the left. So as it shifts to the left, that means this stuff, the chromate ion, is going to go down. All right? And you could have said a couple of things here. You could have actually done a little calculation because they gave you a number. Or you simply could have stated the reaction would shift to the reactant side, or to the left. And here's another little statement you could have added. K would be less than Q. Therefore, the chromate would decrease. So I was looking for decrease. That was one of your points. And then the justification, which had to be correct. So if you said the word decrease, you got a point. If you said you gave it proper justification by either calculating Q, and all I did was just plug in my numbers for Q right here because they told us how much the silver ion was that was added. If you notice how different these two numbers are, you have so much more silver ions present than you do the solubility value. So honestly, you're swamping that system. Here's Q. you go back and you compare that to your original K value, which was 2.6 times 10 to the negative 12. Q is definitely greater than K. So since Q is greater than K, you're forming a precipitate, and the reaction is going to shift to the left. So anything that you said along those lines is what I was looking for a proper justification for that question. All right, last part of the question, we go to the silver phosphate, okay? So they give us the concentration of silver in silver phosphate. Pay attention to what you're given in the problem, all right? They didn't give you KSB, they gave you the concentration of the silver. Then you had to write a balanced equation for the dissolving of the silver phosphate. So if you did not get a point for this question, then you didn't write your charges. That had to be a 3 negative. That had to be a positive. I had to see that on your paper, and that was worth 1 point, okay? On the next part, sorry, I'm having to flip back and forth. Let me just do it this way. It says calculate the value of the KSP for silver phosphate. So write your KSP expression. Notice that one would be cubed because it's cubed in your equation. And then here's where you got your points for that one. You had the value of silver given to you, so you plug it in. Remember, it's cubed. But according to your stoichiometry, you have 3 times as much silver as you do phosphate. So over here, phosphate's not the same number. It's that number of silver divided by 3. If you put that it was divided by 3, you got a point for that. Okay, this was a 2-point question. If you didn't put that and you still calculated K using the correct equation, you still got a point, but you didn't get this point right here. Right, so you got a point for the final answer. When you calculate that, it's 2.6 times 10 to the negative 12. All right, the last question was a 2-point question. Let me read what the question says. The question says, if you have a 1 liter sample of saturated silver phosphate, it's allowed to evaporate at 25 degrees Celsius to a final volume of 500 mils. What is the silver ion concentration in solution? Justify your answer. Okay, so for this problem, I had actually drawn a beaker on the board for you guys, and if you had missed class, that might have been why you missed this question. But as you have water to evaporate, okay, remember, we've got solid stuff down at the bottom. This is our solid silver phosphate down here. Oops, sorry, you can't see that. Okay, so let's say this is our original amount. As water evaporates and leaves the system, little H2O particles, and we drop our level to the final volume of 500 milliliters, okay, as water leaves, those ions that the water molecules are surrounding are going to drop out into a precipitate. They just drop in here. And so they're going to drop out in the same ratio that water's leaving the beaker. Since you've got fewer ions in solution because you have fewer water molecules to pull them into solution, then the original concentration is still going to be the same. It's a saturated solution. So by allowing some of this stuff to evaporate and you haven't changed the temperature, you still have the same concentration. So it says, what is the silver ion concentration in solution? What was it originally? It was 5.3 times 10 to the negative 5th. That's your answer. And then you had to justify your answer. You are still working with a saturated solution. As long as you have some solid in here, the amount of water that's going to leave the system is directly proportional to the amount of ions that are in solution. So water is directly proportional to the ions in solution. As the water leaves, the ions drop out, Ag plus, it's supposed to be an Ag, they become Ag3PO4. They're not in solution anymore because there aren't as many water molecules pulling them into solution. Okay? Think of it like it's kind of a logic thing. If you're you have a whole bunch of people that are couples and you start losing one member of the couple, you don't have a couple anymore. So the number of water molecules that leave are directly proportional to the number of ions in solution. And since we're looking at concentration of silver, which is molarity, which is a ratio, moles per liter. If you lose water, you lose the number of moles of ions in solution at the same ratio. That's your justification. All right, I have to end this video because it is actually a little bit later than it should have been. So you guys get your test corrections done, and I'll see you on Tuesday. Have a good rest of the weekend.